the goal of instruction. When students can perform mathematical operations with speed and accuracy, they are considered fluent. Math education consultant Beth Kakuza explains how this concept is reflected in the standards themselves.
There are fluencies that are required throughout the standards in every grade, and these are the ones where the word fluent actually appears in the standard. The word fluent was used very sparingly for only moments in time when it was absolutely necessary. And it's also very important to note that these are not, just like we've been talking about the focus and the coherence of things, these are not just plopped in randomly at places where now would be a good time for them to be fluent in this. They're the end point of a progression of understanding. So we're not just saying, all right, let's drop into grade 3 and we're gonna know our multiplication and division facts. That is the end point of grade 3's learning. So there's lots of conceptual development and understanding and discussion and deep thought that's going into developing that fluency, and the fluency is expected by the end of the grade.
So if you're doing something fluently, you're doing it with reasonable pace, good rhythm, not halting or stumbling. It does involve issues of time, and of course accurately. The word fluency also has a larger meaning, though, in math education, as many people point out. A procedural fluency in adding it up is a kind of a big idea that takes into account not just fast and accurate results, but also a strategic component and other things. And the Common Core standards don't mean to redefine that phrase, but in the particular standards in which the word is used, it's a much smaller idea. It just means, can you get the answer reasonably quickly and accurately? Fluency, in the balanced way that the Common Core does it, is probably a shift for most people, because it asks us to respect both the journey and the end point. The standards make the investments, ask us to make the investments in the conceptual understanding and procedural development of skill from year to year, and applications that make fluency realistic, and then they insist on it. So, example of fluent calculation would be, if I say 9 plus 4, and I very quickly say, one more will get me to 10, and then I'm at 13, and I say 13. And I quickly and accurately give you the answer 13, but I've done a little mental process. So that's fluency, and most of the fluency standards ask for that kind of fluent calculation, often mental. For younger kids, there may be some sophisticated strategies that they're using to do it, but it's quick and accurate. Memorize is an even more literal command about teaching. Now, the question is, how do we get to the goal? And the standards are partly designed to make this goal reachable. I like to think about the standards as being a number of trajectories, interpenetrating sometimes trajectories of teaching and learning, so the grades are going up. And we have a pinnacle, sort of, and a pinnacle would be being fluent with the multiplication table and knowing your multiplication single-digit products from memory. But getting there is a bunch of reasoning and practicing and discussing and problem solving, learning new particular ideas that get you along the progression to get there. And there are two mistakes you might make. One mistake is to focus only on the outcome and ignore, this goes from kindergarten all the way up to grade 2, for example, knowing the addition, single-digit additions, single-digit sums. Knowing single-digit sums from memory is in grade 2, but a lot of K2 is building toward that. And so people have to understand that you can't short-circuit that and expect to get good results. On the other hand, another mistake would be to conveniently ignore this because it's sort of a lot of work and feels harsh, and to know single-digit sums from memory is a demand, and the instructional program has to have sufficient strategies to make that work. That is going to include timed practice exercises. It's just I can't personally, common sense-wise, see how it doesn't include that. But let me just make concrete what I'm saying about the need to not short-circuit things. So when you're in third grade, multiplication, division are introduced in the standards in third grade, and you're teaching a group of children who have no idea what that symbol means, and you're teaching them what that symbol means, and if they, so if my math is right, that's 35. Well, in the classroom, a good conversation at the beginning of third grade is, well, why is 7 times 5 35? What does that mean? You're asking them to reason mathematically to a conclusion, so you need to have principles on which you can base your reasoning. And so the principle is in Standard 3OA1, and it says the student should understand a product, m times, 7 times 5 is the number of things in 7 groups of 5 things each. So why is 7 times 35? Well, it's an empirical question, 1, 2, 3, 4, 5. How many dots are there? That's an empirical question. I have 7 groups of 5 things each. How many dots? If I did it right, there's 35 dots. This is called a count-all strategy. And students at the beginning of the year, I don't know what other strategy do they have, but to have a principle and a sort of a definition in mind and to use that definition to reach a conclusion. Later in the year, they'll have more sophisticated strategies. They will understand commutativity, what you get when you flip this up. They will understand associativity and other things. And very importantly, they will begin to understand distributivity, without necessarily calling it that. Let's try a new one. 7. Let's do. Yeah, let's do 7 times 5, but let's think it through this way. The students say, well, I actually remember my 5s pretty well, so I'm going to flip it and think about 5 times 7. And I know everyone knows 5 times 2, right? And 5 times 5 is super easy to remember. That's 25, and that's 10. And this addition is actually quite easy. Right, and the answer is 35. And I could imagine doing that as a very rapid reasoning process. That would be called a fluent calculation of 7 times 5.
This emphasis on students developing procedural skill and fluency provides teachers with an opportunity to rethink how they have structured class time and homework. This is the main instructional shift toward fluency. To develop fluency in procedural skill, teachers are encouraged to structure class and homework times so students spend their time practicing core functions, such as multiplication facts. This way, students are able to understand and manipulate more complex concepts. However, the journey begins with developing that deep conceptual understanding of the process of multiplication. Another aspect of developing a deeper understanding of core